Hey, what's poppin'? It's your host Jared with Robotic Engineer Automation. What's going on, guys? Today we're gonna be doing something a little different. Today we're gonna be doing a React video. I've seen a couple robot videos pop up online. We're gonna have a discussion about it, and then we're gonna be done. Real quick, if you guys have questions, throw your questions in the comment sections. I try to be very responsive to everybody. I also wanted to mention if you need help on your application, you need a consultant, service work, or you just want to have a back and forth discussion, email me and we'll see what we can do. I've recently had a subscriber email me about a vision application system. It was a unique application system, so I was able to give them some valuable feedback. But I was also able to have a learning experience for myself too because I've never done something like that. So I really enjoy having this feedback with my subscribers. So feel free to shoot me an email. So if you guys like the content, hit it with the like, and if you gained value from the content, hit me with a sub, you moocher. Without further ado, let's get into it. So here we have a video from Zach D Films. It's a guy getting crushed by a robot. So let's check it out here.
The robot arm clamped onto him, crushing his chest and face against the conveyor belt. You see, these robots were designed to grab boxes of vegetables and place them in line. But something went horribly wrong when the robot mistook the man for a box and grabbed him instead. Now, some think it was because the man was holding a box, which confused the robot. After he was crushed, other employees rushed him to the hospital, but his injuries were too severe and he died.
And he did not make it. So there's a couple of things I want to go over in this. For one, these are industrial robots. I'm not sure of the brand, but I do know that these are industrial robots, especially these cases of vegetable cases. I mean, these have got to be some pretty darn heavy boxes, which I don't think there's a collaborative robot out there that has a payload exceeding 25 or 30 kilograms. So if it's over 60 pounds, it's going to be an industrial robot. And plus, the animation looks like an industrial robot. So we can only assume that these are non collaborative safe robots. They're not the kind that you should be working near or next to during their normal operations, especially when they're in auto mode. So here is my take on this. It says that um, it was thought that the robot mistook the human as a box, which is kind of goofy to me because it's not like the robot's very sophisticated, right? It's in fact it's very unsophisticated. If something's there, it's gonna grab it, it's gonna pick it, it's gonna place it. Um, the conditions had to be just right, right? Like the human had to be in the position where the robot happened to be going. What I think this application is I think this is a depalletizing application. It's picking from what appears to be a pallet and is placing onto an outfeed onto a conveyor. That the conveyor is what said is what crushed him. I personally believe that this man entered the cell, whether there's a fence or not. He came into the cell and he probably fixed the pallet. There's probably something wrong with it. Either it wasn't, straight. He probably tried to square it up, try to straighten it up, try to make it more repeatable. Either way, the operator went in there to intervene. Whether the robot was already in its auto cycle or whether somebody had started it remotely from a push button box, a cycle start push button, is unclear. One thing that I think happened here is that this operator entered the cell, came near the robot picking station, and just so happened to be the perfect condition where he was in the area where the robot was picking. The robot picked it, didn't realize it, didn't care because it's an industrial robot. Doesn't give a crap about a 50-pound payload difference. Um, it's gonna pick it and it's gonna place it, and it ultimately killed him. So this is a sad situation, especially if it's true. I don't know if it is or not, but it's something that's happened before in the past. So it's absolutely a realistic scenario, especially when you lack the proper safety peripheral devices, gate lock switches. Now, I know one thing that our customers are doing are starting to request that they have these lock keys, which require an operator to unlock the gate, open the gate, take the key. Well, first they have to turn the key to be able to even unlock the gate. They have to turn the key. You can take it out. The operator puts it in their pocket and they go about their business inside the cell. If somebody on the outside of the cell, a second person, tries to close it and start it, it will not lock the gate without the key being in there, and the system will not start in auto without the gate being locked. So it's just an extra step of redundancy required to prevent something as horrific as something like this from happening. Even in instances where there isn't a key, the gate lock should still be getting locked out, essentially. The gate lock should still be getting locked out. There is another video I wanted you guys to watch. It is kind of a goofy video. Obviously, it's from a different country. Let's just watch it. First, I want you guys to pay attention to this robot here. Again, this is another application where these are industrial robots, and there are humans working in or around these unsafe robots. It's an extremely unsafe situation. So here we see, you can kind of see it's a little bit distorted, but there's a man standing here. And in the first 5 seconds, you're going to see this robot sweep over. It's going to sweep, which is going to hit him, but it's not enough of a collision to stop the robot. The robot doesn't stop until he's pinned. Full disclosure, nobody gets killed, nobody gets murdered, there's no blood or anything. The robot sweeps over, hits him, and then pins him when the robot tries to place its product onto the outfeed conveyor. That is when this man gets pinned. And that's when all hell breaks loose in here. You're going to see people start responding. You're going to see people start coming in to help him. The first thing these people should have done is call maintenance personnel, get a robot engineer, get an engineer, get somebody over here that knows how this robot teach pins work to jog the robot up out of the way. So let's see him get pinned here. He comes over, he gets swept, and it pushes down. Do you see how it's kind of arcing the end of arm tool? That's when the robot starts to push down on this man. So he really, really gets pinned in on this conveyor. You can see this man, he runs over here to what I think is the teach pendant, but ultimately eventually gives up. Here's what you don't see happen. A single person hit an emergency stop. That's what they're designed for, and I'm almost positive these robots come with an emergency stop, so at some point in the integration stage, integrators and people commissioning these robots had to integrate the e-stop into the cell. Who knows how it works, but there are emergency stops on the cell, and nobody presses him. So he runs over what I think is the teach pendant. Now, if you've ever had a robot collision, and if you're watching my channel, I assume you probably have, and you know it's not a very easy task to recover from a collision, especially depending on its intensity. It can be excruciating to recover from a collision sometimes. But on average, it could take about 60 seconds to recover. Once somebody grabs the teach pendant, it could take me about 60 seconds to recover. Because if you remember, on a FANUC teach pendant, you hit the dead man, you hit shift, go positive Z, and it increments a little bit. The robot still has that servo feedback. The robot realizes that it's taking more energy to move the robot than what's necessary. That's how the robot knows that there's a collision. And that's why the robot initially stops here. That's why it doesn't continue on its job, because it knows that it has a collision. It detects the collision and it stops the robot. Right then, right there, that collision should have took the entire system out of its automatic cycle. But it didn't. Keep in mind, again, nobody pressed an e-stop. This is still running. This is still running. This whole system is still running. The only thing that's not running is this robot. Okay? I want you to keep an eye on the bottom right corner of your screen. People are going to start flooding to him. They're going to hear him screaming. They're going to react. They're going to start coming over to help him. And boom, these two guys. It's not funny. It's not funny, but it kind of is, because they're not dead. They're feeling it. I'm sure that they're feeling it, and I'm sure it hurts like hell. This is just chaos. It is complete chaos at this point in time. These guys are very fortunate that this conveyor did not turn on. The robot, here's what I think happened. I think the conveyor is still running its cycle, just like everything else is, right? Even though the robot's faulted, everything else is still running its cycle. The conveyor is waiting for the robot to place its product. The robot never makes it to its place product position, and thus the product is never present. Thus, the signal's never sent. Thus, the conveyor never turns on. So that's why I think these guys are extremely fortunate that this conveyor didn't turn on, because I think that would have been extremely unpleasant. So my breakdown of this is just a mess. This is just a mess. Okay, for one, you don't work next to industrial robots. Step one. Step two, At the very least, if you're not going to put gate locks in here, you're not going to put a safety fence and restrict personnel, then at least invest in an area scanner or two. Because what an area scanner could do is it could give operators more time to respond to a robot that's actively moving. Because clearly, this company doesn't want to stop the system if operators are present. So at the very least, at least use an area scanner to put the robot in a collaborative speed. Collaborative speed is 250 millimeters per second. All that's going to do is going to give the operator more time to respond to get out of the way of its path. If the operator doesn't, the exact same thing is going to happen. It's going to come over and sweep, and it's still going to pin him up against the conveyor, except if the area scanner is blocked, it's going to do it in a much slower speed. I mean, this is just absolutely insane. Conveyors are still running. I mean, this is just absolute chaos. Yeah, I've been watching John Wick 4. It was awesome. That's all I got today, guys. I just wanted to go over a couple of those videos I saw on the internet. Keep an eye out. I'm going to be posting some more videos coming out. The next video I'm going to be posting is a DCS video on Fanuc Robotics. So I appreciate you guys tuning in. If you like my content, hit it with a like. If you find value in my content, hit me with a sub. Keep an eye out for more content. I will continue to deliver content that is missing on the internet, nowhere to be found except here at Robotic Engineer.